Hey guys, welcome to question FM134 of the Further Maths Fortify study guide. So this question reads, the purchase price of a genuine iron throne replica is $20,000. A deposit of $6,000 is paid and the balance will be repaid with 24 monthly repayments of $700. The annual effective rate of interest is closest to what? Now there are two steps to solving this question. Number one, we're going to have to figure out what the nominal rate of interest is, and then we're going to have to move on to finding the effective rate of interest. Now, if you are coming to this video because you think the answer is E, when it has been listed as D, then you are correct. The answer is E. That's a misprint on our part, so you can stop watching the video. If you have an early version of our book, the answer is E, not D. So feel comfortable there to leave off and go to the next video. Otherwise, if you're not sure how this question is solved at all, stay on board and we'll solve it now. So first of all, we're going to use a finance solver in our calculator. Now we're using this to find the nominal rate of interest, and then we're going to use that nominal rate to find the effective rate. So first of all, what we know about this loan so far, so the purchase price of the genuine iron throne replica is $20,000 and a deposit of $6,000 is paid. The balance, so the balance that's left after that $6,000 is paid on the $20,000 item is going to be $14,000. So that's how much is still owed. That's how much has been effectively given to the customer that they haven't had to pay for yet. So we leave that as a positive amount because that's how much they owe still. That's how much is being given to them. Our interest, of course, is what we're going to be solving for. We know that this balance is going to be repaid with 24 monthly payments of $700. So we know there's going to be 24 monthly payments, which means that our payments per year, and assumedly our compounds, are going to be 12. Payments of $700 means that we're going to lose $700 at each payment, and our future value, we're going to repay this balance with that 24 monthly payments of $700, so we can assume that that future value on that loan is going to be zero. We're not going to be in debt at all anymore. So plugging this into the old finance solver and solving for the interest is going to give us an answer along the lines of 18.157. Now that is the nominal interest rate, which of course is not the effective interest rate. The effective interest rate is going to be slightly higher because of these 12 compounds that are happening each year. So we're going to use our effective interest rate formula. So in case you guys aren't familiar, that's that our rate, our effective, is going to be equal to 1 plus our rate divided by n. N's the number of compounds per year, number of payments per year, over 100 to the power of n minus 1. And then we're going to times that amount by 100 to get a rate, so to get a percentage version of this answer. So plugging all of this in, we're going to have 1 plus, now our rate at the moment is 18.157. So we're going to have 18.157. And of course there are 12 compounding periods in this scenario. So n is going to be 12 to the power of 12 minus 1, and then all of that times 100. When you plug this into your calculator, you should get an answer along the lines of 19.747, which of course is closest to 20, landing our answer at E. If you guys have any questions on how I did this, please drop them in the comments below. Otherwise, I'll see you in the next video.